Electricity. It helps us to be the masters of our environments. Most of us take electricity for granted. But if there is a power cut for a long period of time, everything in our modern world stops functioning. We get a sense of what life was like more than 150 years ago, before power transformed our society and our lives. Today, we control our climate, process information, and tend to our health and do many more things with power that flows hundreds of kilometers across an interconnected transmission grid. Electric current, the flow of charged electrons, intimately influences how we live. Yet, most of us understand very little about how it's made. The SCCL has entered into power generation as part of its diversification plans by establishing a 2 into 600 megawatt Singareni thermal power plant. Both the units started power generation in 2016 and are running efficiently since beginning. In fact, SCCL is the first public sector coal mining company in India to enter into power generation. Millions of units of power has been generated from both the units and was exported to the grid. These thermal power units achieved 100% PLF, plant load factor, many times, and the power plant has achieved 5th position amongst all the thermal power plants in the country in 2017. Now, let's see how electricity is generated from coal by taking a tour of STPP, a coal-fired power plant. This plant has 2 generating units, each of 600 megawatts, that produce 1200 megawatts of electricity at full capacity. This one power plant can produce enough electricity to supply to the needs of twin cities Hyderabad and Secunderabad in Telangana state. Generating electricity requires a fuel source. At this plant, the fuel source is coal, which arrives from Srirampur, Medipalli and Bellampalli open cast mines of the Singareni Collieries Company Limited. These open cast mines deliver about 16,000 tons of coal every day to keep the plant running. This plant uses about 15,000 tons of coal each day, and over 2.5 lakh tons of coal is stockpiled next to the plant. The quality of the coal has a lot of impact on power production. STPP needs coal of G11 grade with 4,200 GCV with ash content of about 30%. If the coal is of lesser quality, more coal needs to be burned to produce the rated power, which increases the cost of production as well as ash percentage, which further creates problems in ash evacuation. Coal from mines is transported to the plant by a coal rake, which is loaded at coal handling plant at Srirampur. A 21-kilometer track has been built by SCCL for transporting the coal to the power plant. These rakes are unloaded onto a track hopper, which is having underground bunkers with 6,000 metric tons of capacity. The coal is then scooped onto a belt conveyor that can transport up to 1,400 tons of coal per hour into the crusher houses, where raw coal of about 200 mm size is crushed into 20 mm size and is conveyed through various conveyors into the boiler feeder bunkers. The coal is then measured and is moved to the bowl mills. These bowl mills have 3 rollers attached to a vertical shaft, and crushed coal from the crusher house is pulverized up to 40 to 70 microns in size, which appears to be like a fine powder. Now the finely powdered coal leaves ball mills and heads to the boiler. About 70 tons of coal can be pulverized per mill per hour. Atmospheric air is preheated and becomes warm air. This air sucks the pulverized coal from the bowl mill and supplied to the boiler through the burner. The purpose of air heating is to remove the moisture content in the pulverized coal and thereby improving the boiler efficiency. Water is another primary requirement in power generation. STPP is having two sources of water. 1 TMC of water from river Godavari and another 2 TMC is being drawn from river Pranahita. Raw water is stored in a water reservoir. The reservoir's capacity is 25 lakhs cubic meters, which is sufficient for 15 days of plant operation. Water from the reservoir is supplied to pre-treatment plant, where alum and soda are mixed to remove primary coagulants, and then the water enters the demineralization plant, where it is conditioned to basic nature. The boiler has thousands of tubes filled with purified water. Once the water is inside the boiler, the coal powder is ignited initially using LDO and HFO. This generates intense heat that changes the water inside the tubes to very hot steam. This process generates thermal energy, which is transformed into mechanical energy at the turbine, which is the next stop on our tour. High pressure steam enters a series of turbines from the boiler. Each of the two units have a high pressure turbine, an intermediate pressure turbine, two low pressure turbines, and a generator. These turbine and generator sets are manufactured by BHEL at Haridwar. The steam from the boiler heads to the turbine hall where the turbines are housed. Each of these turbines are about the size of a bus. These turbines spin a drive shaft connected to a generator. When the steam hits the turbines, its explosive pressure spins the blades at about 3000 rpm. The blade tips travel almost at 1.5 times the speed of sound, pumping out few lakhs of horsepower. In this process, the steam turns the series of turbines and rotates the generator at a speed of 3000 rpm, which creates electromagnetic force and produces 21 kVA. Which is stepped up to 400 kV through transformers and is transmitted through 400 kV switchyard to the power grid. So, basically burning coal boils water to make steam and spin many tons of stainless steel to create thousands of volts of electricity. The generator continuously creates an electrical charge of 21 kVA of electricity, which is equal to 600 megawatts, that is 6 lakh units per hour. The total power generated by each unit is 144 lakh units, and a total of 28.8 million units of power is generated by STPP every day. From here, the electricity leaves the plant and begins its journey to the customers. Meanwhile, the steam that has been used to create electricity is sent to a condenser to be changed back into water. The steam condenses to water and returns to the deaerator, where oxygen will be removed and sent back to the boiler through boiler feeder pumps to repeat the steam generation process over and again. As steam condenses, the chilled water inside the condenser pipes becomes warm from the heat of the steam, so it is sent to a cooling tower. At STPP, induced draft cooling towers are constantly at work, where cooling is done by mechanical fans. There are 44 fans, out of which at least 40 fans will be working throughout the day. The freshly chilled water returns to the condenser to repeat the process of cooling more steam. all these operations are controlled in common control room, where each unit is having separate large display video screen which displays all the parameters regarding that particular unit. In each shift, there will be shift in charge and a minimum of 4 desk operators for each unit who control the boiler, turbine, electrical and water system parameters. All the people in the control room are either electrical or mechanical engineers having knowledge of MaxDNA, a software used by STPP which is made by BHEL's Electronics Division at Bangalore. The function of control room is to maintain the system in auto mode as per rated norms. Apart from the control room, there are coal handling plant and ash handling plant control room operations controlling the coal flow and ash evacuation. Water chemistry is closely monitored by demineralization plant's team all through the day, as water chemistry will have a lot of impact on the boiler and turbine performance. STPP is equipped with CEMS, Continuous Emission Monitoring System, to monitor sulfur oxides, nitrogen oxides and particulate matter called fly ash. All the data collected is being constantly monitored by various state and central government authorities. Fly ash is collected through electrostatic precipitators and transported from ESP hoppers to fly ash silos through pressure conveying system, from where it is disposed to cement industries. About 90% of fly ash produced at STPP is being distributed to other industries like cement, fly ash brick manufacturers, etc. for free. This is a win-win strategy, as manufacturers get raw material at zero cost and STPP can easily manage the fly ash that is produced while generating power. Usually, precious river sand is used for stowing in underground mines. But at STPP, we have an added advantage regarding bottom ash disposal. Bottom ash from the boiler is collected into hydro bins, and from there, bottom ash is disposed to Srirampur underground mines for using in stowing activity. STPP plant is unique in ash utilization, and also water used in every process of producing power is being recycled. That's why STPP is a zero discharge plant. This is how STPP generates electricity without much impact on our environment. Apart from coal-based power production, SCCL is also venturing into solar energy production. We are planning to produce 500 megawatts solar power within the SCCL areas in the next 3 years. A 50 megawatt solar power plant in the Ramagundam 3 area is in pipeline, and to meet the auxiliary power consumption at the STPP, we are planning to set up a 10 megawatt solar power plant at Jaipur location. We at SCCL have vision to be one of the best power producing companies in India in the future. We are empowering the growth of Telangana state as well as our nation. The current installed capacity of 1200 megawatts is not the end of our story. It's just the beginning of a journey. After this tremendous success in a very short span to utilize the existing infrastructure at STPP and to meet the power demand in the state of Telangana, we are going to establish another 800 megawatt supercritical unit at the STPP with an investment of about 5,200 crore rupees, which has been approved and the work is in progress. In India, as of now, majority of the power generation is coal-based. Even though the share of renewable energy sources will increase substantially, it seems coal will still be the major source of power for at least the coming few decades. With growing energy demand in the country, coal and the renewable energy will play a major role in power generation, and we are ready to take up the challenge to provide clean energy to the nation's power needs.
So ఈ ప్లాంట్ కన్స్ట్రక్షన్ చేయడం కోసం ఇక్కడ జైపూర్ దగ్గర దాదాపు 2000 ఎకరాలు మేము ఈ నియర్ బై విలేజ్ నుండి తీసుకోవడం జరిగింది. ఇంటింటికి 2 ఫ్రూట్ అంటే పళ్ళ మొక్కలు కూడా లాస్ట్ ఇయర్ దాదాపు 7000 మొక్కలు పెంచాము. అలాగే ఈ ఎఫెక్టెడ్ విలేజ్కి కమ్యూనిటీ హాల్స్, ఆర్ఓ వాటర్ ప్లాంట్స్ ఇవి కూడా ప్లాన్ చేసాము. దే ఆర్ అండర్ పైప్ లైన్. Within 2-3 months they are going to start RO water plants. Next roads gaani other activities also we are providing to them.
At STPP, we believe that with dedication and teamwork, no challenge is impossible.